So question 16. Here is part of a shopping bill for clothing. So we have one jacket at a price we don't know, one shirt which is £29, total cost before discount we don't know, we do know there's a 10% discount, and the total to pay after the discount is £80 and 10p. So work out the cost of the jacket before the discount. So if there's been a 10% discount, I know that £80 and 10p equals 90%. Yeah, that's 90% of the original cost. So I need to know what 100% is. So the way that I would do it is I would go 80.10. Now I would divide this by 9, because this would tell me then what 10% is, and then multiply by 10. Okay? Or you could divide this by 90 and then multiply it by 100. That will still work, okay? I'm just used to doing things in a shortcut fashion. So £80 and 10p divided by 9 gives me 8.9, and then I multiply this by 10, gives me £89. So £89 is the full cost. Okay. Now he only bought one jacket and one shirt. So if we take off the cost of the shirt, this will equal the jacket. So I would write full cost minus jacket cost minus the shirt cost. This is what happens when you try to do things quickly. Minus the shirt cost will equal the jacket cost. Okay, so £89 minus, now we need the cost of the shirt, which is £29, equals £60. So we can say that the jacket costs £60. So you can see it's quite simple really, you know, it's just a question of what do I know, what do I need to know, and then how can I get there. What's important is that if there's a 10% discount, that this is 90%. What students have a tendency to do then is divide this by 10 and then add that on. That's not right, because 10% has already gone. So you need to divide by 9 to find out what 10% is. Okay, so it's quite a simple question, but it's just a question of holding your nerve and then working through it step by step. Okay, so we'll pause this and we'll go on to the next question. Okay, so question 17. A is the point with coordinates x and 2y. B is the point with coordinates 3x and 4y. The midpoint of AB has coordinates -4 and 15. work out the values of x and y. So if we have, okay, a very tatty graph, but if we have a point here and a point here, and then we just join these two together, this would be the midpoint. Yeah. So let's say that this is 1, 1, and let's say that this is 5, 5, just for argument's sake. Then to find the midpoint, I would add the two x's and divide by 2. So 1 plus 5 is 6, divided by 2 is 3. And then the same with the y-axis, so 1 plus 5 is 6, divided by 2 is 3. So I know the midpoint is 3, 3. So I add these axes together, divide by 2, and that will give me this value. Here, add these values together, divide by 2, and this will give me this. So we're just going to do the same here. We know where the midpoint is. So for the x's, this would be, I would write x value equals, so this would be x plus 3x, okay, so it would be that plus that. We would then divide this by 2, and that will give me minus 4. Minus 4. So I can say that 4x over 2 gives me minus 4. So obviously 4x divided by 2 gives me 2x. So 2x equals minus 4. So I can say that x equals minus 2. Okay, very simple. Very, very simple. Now for the y values, I'd write the y value would equal 2y plus 4y. This would all be divided by 2, and that will equal 15. Okay, so all we do now is 2y plus 4y is 6y divided by 2, and this will equal 15. Therefore 6y divided by 2 is 3y equals 15. So y must equal 5. Okay, so x has a value of minus 2 and y has a value of 5. Okay, so if you understand midpoints, okay, like this, it doesn't hurt if you do this in an exam and go, well, how do I find midpoints, and jog your memory. Then that will tell you how you can find the solution to this problem. Okay, so that's finding the midpoints with unknowns. So we go on to the next question. Okay, so question 18a. So we have a triangle here, right angle triangle with two sides and an angle that's missing, and they want us to find the angle x. So this is going to be trigonometry. Okay, so if you remember SOHCAHTOA, then you're okay. Remember, sex on hard concrete always hurts the other's arse. So okay, sex on hard concrete always hurts the other's arse. So this I know is sine, this I know is cosine, this I know is tan. Please do not write on the exam paper sex on hard concrete always hurts the other's arse, okay? Because I've taught it to you that way doesn't mean examiners may approve, okay? You might get a prudish examiner. So we have here the opposite to the angle, and we have the adjacent to the angle. And I can see here the opposite and adjacent means that I use tan. So tan x equals opposite over adjacent. Okay, write this so examiners know what you're talking about. Okay, so tan x equals, now the opposite is 7 over the adjacent, which is 12. Okay, and that's going to equal, so on your calculator you can now put this in. So 7 divided by 12 gives me 0.58, and then we just get 3 recurring, 3, 3, and so on. Okay, now I would just go to 3 decimal places. Now obviously this angle can't be 0.5833 degrees, okay? So what we need to do is we need to find what the angle is. So remember, we press shift, okay? So we press shift, tan, and then 0.5833, and we get an angle of 30.255 degrees. Now if you look at that, that seems more sensible, doesn't it? 30 degrees or so. So our answer is 30.255, and they've put the units there, degrees. Okay, so this is quite a nice simple question. So we move on to the next question, 18b. So here we have a scalene triangle, and it says work out the length of BC. So they want us to find this length here. So I'll call this X now. Remember, the side opposite the angle is labelled up accordingly. So this is little a, this is little b, and then C doesn't come into the equation because we don't have the angle or the length C. Now because we have matched pairs, we can use the sine rule, and we're looking for a length. So little a over sine a equals little b over sine b. Okay, and this is given to you at the beginning of the paper. Now little a we don't know. Sine a, So this would be sine 40 equals, now little b is 18, and this would be over sine 110. Okay, so we need to rearrange this so we get little a on its own. So little a equals, now sine 40 is being divided here, so if I move it over it will multiply, so we'll have sine 40 multiplied by 18, and this is all going to be divided by sine 110. Okay, so now this is where our calculators take the strain. So we have angles, so we don't need to press shift, so we press sine 40, close the bracket, multiplied by 18 equals, and this is going to be divided by sine 110, close the bracket, and that gives us a length of 12.31. Okay, so this length here is 12.31, and centimetres are already there for us. Okay, so that's question 18. So I'll go on to the next question, so I'll just pause. Okay, so question 19a. The table shows information about the travel expenses of employees at a company. The amounts are in pounds. So the minimum travel expenses was £9, the highest value was 45, lower quartile 18, upper quartile 30, and the median 23. All we've got to do is draw a box plot. So this is nice and simple. They've scaled everything up for us. So our lowest value is £9, okay, and each one of these little squares is £1. So at £9 I will put in a line. My highest value is 45, so at 45 I will put in another line. Now my lower quartile is 18, so I would go to 18, and I would just draw a line here. My upper quartile is at 30, so again I would just go to 30 and drop the line in. And my median is at 23, so 20, 21, 22, 23, so I would just go to 23 and drop that line in, and all I need to do is connect everything as it should be, and there we have our box plot. Very simple. That's it. I don't know how many marks they give us for that. Oh, 2 marks. So this is our lowest value here, our highest value here, and then the 2 quartiles form the box, and the median is the line in the box. Okay, nothing more complicated than that. Okay, so I'll pause and I will go on to the next question. Okay, so this table shows information about the distances the employees travel to work. So 17 travel from 0 to 10, 12 from 10 to 15, 3, 15 to 30, and so on. And we need to draw a histogram. Okay, Now the histogram, they've drawn the graph for us. They've put our distance here and our frequency density here. So all we've got to do now is work out our frequency density. So I would write frequency density. So I know how far to come up to frequency density. And remember, frequency density, okay, is frequency divided by class width. Okay, so it's frequency divided by class width. So our frequency here is 17. Now our class width from 0 to 10 is 10. So 17 divided by 10 gives us a frequency density of 1.7. Okay. Now here we have a frequency density of 5. So this will be 12 divided by 5, which I believe will give us 2.4. And then here we have a frequency density from 15 to 30, so we have a frequency density of 15. So this will be 3 divided by 15. So 3 divided by 15 is 0.2. And then here we have a frequency density again 30 to 60. So we have a frequency density of 30. So this would be 9 divided by 30, which gives us 0.3. Okay. So this, the frequency density, tells us how far up the frequency density line we come to top off our bars. Okay, so from 0 to 10 we want 1.7. okay, now sorry, but I'm going to have to jump up and down a bit here. So 0 to 10 would be 1.7. So from here to here would be 1.7. So I just need to scroll this a little bit more. So 1.7, now from here is 1.6 and that's 1.8, so 1.7 will be there and my bar would go to there. Okay. So there's my first bar. So that's from 0 to 10. Now 10 to 15 is 2.4. So 10 to 15 is 2.4. So we're going to have a very narrow bar here. So that's going to go up to 2.4 here. And it's only going to come across one set of squares here, and then this will come down here like so, and that will join up there. Okay. Now we have 15 to 30 is 0.2. So from 15 to 30 is 0.2. So 0.2 is along this line here, and from 15 to 30 would be here. And then the final one, 30 to 60 would be 0.3. So from 30 to 60 would be 0.3. Now 0.2, 0.4, so it's going to fall around there. And 30 to 60 is going to be about there. Okay. And there's my histogram. Okay, and you can see here that the bars are all different widths. Now if I was given this bar chart here, this histogram here, remember the area is the frequency. Okay, so this distance here is 30, this is 0.3. Now 30 multiplied by 0.3 will give me 9, which is exactly what I've got. Okay, so quite a nice question there. Okay, so I'll stop there and I'll do a video for the next set of questions.